A dying plant can look thirsty, even while its roots are drowning. The leaves sag, the color fades, the soil stays wet for days, yet our first instinct is to pour in more water. Then someone reaches for the little brown bottle in the medicine cabinet. Hydrogen peroxide touches the soil, white bubbles erupt, and for a moment it looks as if the plant is coming back to life. But what are those bubbles actually doing? Are they killing root rot, feeding oxygen to suffocating roots, or quietly burning the last healthy tissue the plant has left? The answer is more complicated and far more useful than the miracle videos suggest. Before touching the bottle, look beneath the soil. Healthy roots are usually firm. Depending on the plant, they may appear white, cream, tan, or naturally darker. Rotting roots are different. They become soft, slimy, hollow, or easy to pull apart. They may smell sour or swampy. Above the pot, the plant may wilt, yellow, drop leaves, or stop growing. Those symptoms do not prove root rot by themselves. Underwatering, cold damage, fertilizer injury, poor light, and compacted soil can look surprisingly similar. But when wilted leaves appear above soil that refuses to dry, the roots deserve an inspection. The real disaster begins when water fills the air spaces in the potting mix. Roots need oxygen for respiration. When the mix remains saturated, oxygen moves through it far more slowly. Fine feeder roots weaken and die. Wet conditions then favor organisms such as Pythium, Phytophthora, Rhizoctonia, and Fusarium. What people casually call root rot may involve different pathogens, and a kitchen bottle cannot diagnose which one is present. Now pour hydrogen peroxide onto exposed organic material, and the show begins. Ordinary drugstore peroxide is usually a 3% solution of hydrogen peroxide in water. The molecule is unstable. When it encounters enzymes, metals, microbes, soil particles, or damaged tissue, it rapidly breaks down into water and oxygen. The escaping oxygen forms the fizz. That bubbling is a chemical reaction. It is not proof that a disease has been cured. It is not the sound of roots breathing. And it does not mean the liquid can permanently oxygenate a waterlogged pot. Most of the reaction is brief, while the drainage problem remains exactly where it was. Hydrogen peroxide can damage bacteria, fungi, algae, and other cells because it is a powerful oxidizer. That is why peroxide-based products are used as disinfectants in commercial horticulture. But oxidation is not intelligent. The liquid cannot identify a pathogen and politely leave every root cell or helpful microbe untouched. At a high enough exposure, it attacks living plant tissue too. In a United States Department of Agriculture study, potted nasturtiums were watered with several low peroxide concentrations. The treatments did not provide a consistent improvement in plant growth. Higher tested concentrations reduced foliage, dry weight, and flower production. The researchers concluded that reports of dramatic improvement were more likely connected to suppressing disease in some containers than to peroxide directly stimulating the plant. A separate controlled study dipped Phalaenopsis orchid roots in 0, 3, 6, or 12% peroxide for 3 minutes. 6 and 12% caused permanent root damage. Even the common 3% strength caused a minor setback and failed to eliminate the algae being targeted. The researchers advised consumers to concentrate on correcting care and watering practices instead. That study involved orchids, so it cannot predict the exact reaction of every houseplant, and that is precisely the problem with universal internet recipes. A thick-rooted orchid, a delicate fern, a succulent, and a young seedling do not share one safe dose. Plant species, root condition, exposure time, temperature, and the amount of organic matter all change the result. So what happens when diluted peroxide is poured onto a dying plant? It may temporarily reduce some exposed microbes. It may create a spectacular burst of bubbles. In certain situations, a carefully labeled horticultural peroxide product may help control specific pathogens when used exactly as directed. But a homemade drench may also injure surviving roots, disturb beneficial organisms, and create false confidence while the plant continues sitting in saturated soil. Start by sliding the plant gently from its pot. If the root ball is merely dry and firm, root rot may not be the problem at all. If the mix is soaked and the roots are soft, Separate what is alive from what is already dead. Healthy tissue resists gentle pressure. Rotten tissue collapses, peels away, or hangs like an empty thread. Remove loose, contaminated potting mix without tearing the remaining roots. With clean, sharp scissors, trim only roots that are unmistakably dead or mushy. Clean the blades before and after the job so the tool does not carry disease to the next plant. If nearly the entire root system is gone, rescuing a healthy stem cutting may offer a better chance than trying to save the original base. Choose a clean container with open drainage holes. A decorative pot with no exit for water is not a home for recovering roots, it is a reservoir. Use fresh, well-draining potting mix appropriate for that species. Ingredients such as bark or perlite can increase airspace, while the correct balance depends on whether the plant is an orchid, a tropical foliage plant, or a succulent. After repotting, watering depends on the plant and the moisture of the new mix. Do not automatically soak every rescued plant, and do not follow a rigid calendar. Check the soil and learn the needs of the species. Recovery will not be proven in 24 hours. Leaves that were badly damaged may never become green again. The real evidence appears later. The decline stops, stems remain firm, and new roots or leaves begin to form. Depending on the plant and season, that may take weeks. If you still choose to use hydrogen peroxide, treat it as an uncertain intervention, not plant food. Use only ordinary 3% household peroxide, never industrial or high-strength concentrate. Never pour it straight onto roots simply because 3% sounds weak. There is no single scientifically established household dilution that safely cures root rot across all species, so test cautiously on a small area or skip the treatment entirely. Never mix peroxide with bleach, vinegar, fertilizers, pesticides, or other cleaners. Wear eye protection and gloves, and keep the bottle away from children and pets. The fizz is real too, the chemistry is real, the antimicrobial power is real, the miracle is not. Hydrogen peroxide may suppress certain organisms under controlled conditions, but it cannot rebuild roots that have turned to mush, correct a sealed pot, or keep careless watering from flooding the soil again. More is not better, stronger is not faster, and bubbles are not proof of healing. The rescue begins when the cycle that caused the damage is broken. Remove the dead roots, replace the contaminated, airless mix, restore drainage, change the watering habit, then give the surviving plant what no brown bottle can provide: stable conditions and enough time to grow a new root system. When a dying plant finally pushes out a fresh leaf, the most important transformation is hidden below the surface. Not a burst of foam, but a small living root extending into clean, airy soil. That quiet growth is what recovery actually looks like.